Welcome viewers to my lecture on mechanization and automation. In these lectures, I will discuss about what is mechanization and what is automation, how to quantify mechanization and how to quantify automations, what are the benefits I am expecting from a mechanized system or automated system, and lastly how to quantify this mechanization and automation. Let me start with an example, very simple example, a lathe operation, very simple example. This is a job, this is a job holded in a lathe spindle, and this is of course cutting tool, this going and cutting, this going and cutting, going and cutting. Now, how it cuts? It will cut only if it is rotated. So, who will rotate this? Obviously, at the behind there is a motor, we call it spindle motor. That means, here this motor is generally now it is electrical motors. That means, this electrical energy is converted in here into mechanical energy. Now, keeping this view in background, as far as name suggests that this induction of machine into industry, that means use of machines for the purpose of getting some kinetic energy, more clearly it is velocity. This energy used for the purpose of getting the work. That means, and what type of energy? This energy we categorize as non-living sources of energy. Non-living sources of energy. What are those? That may be electricity, which is produced by burning coal or from hydraulic energy. All these are category chemical energy, all these are called non-living of energy. That means electrical energy, example non-living of source of energy, electrical energy, chemical energy, electrical energy, hydraulic energy, chemical energy, then in nuclear energy also. All these are and so on, all these are called energy from non-living sources. Non-living sources of energy. This energy is used for getting the work. So, ultimately what happens? Why I am using this energy? Because of the fact I want to replace my physical labor. That means, if I want to rotate by some gearing arrangement, then I have to do some physical labor. I want to replace that. So, mechanization. So, in other words, I can tell that mechanization is used for replacement of human physical energy, right, where control and decisions still remains in the human hand. Then how do I formally define mechanization? I can formally define mechanization. Mechanization as like this. Mechanization may be defined as the use of energy of a non-living system to carry out a process or process operations, wherein, as I told you, the control and monitoring of which are fully performed by humans. So, what are the objectives of mechanization? First objective is, as I told you, to reduce the labor cost, to improve the working conditions, and to increase obviously quality of products, and to increase the productivity also. Say again, let me come back to my operation, to my examples. Okay, my physical labor is replaced by some energy from electrical or hydraulic or nuclear systems. The tool reaches this point. Okay. If I consider there is a lead screw or something like that, means once this tool reaches this point, movement of the tool is ceased. That means it has to stop moving towards these directions. Now, not only that, again motor in this direction starts, motor in this direction stops. When it is stopped, then it starts, tool is moving this direction. When this position reached, again motor in this directions is stopped. So, movement along this direction is ceased. Again motor in this direction not only rotates, but it has to rotate in reverse direction. So, that it goes towards direction, it goes towards direction. So, it has to rotate in reverse direction. Then again if it is here, this motor stops, this motor rotates in reverse directions, so that it can go to its original position, so that it can operate further and another cycle. So, all these decisions who has to take? In a normal machining operations, conventional machines, the operator has to take these decisions, but in an automated manufacturing systems, this decisions is taken care of by the machine itself. Of course, with some pre-feed data, normally we call the program of the machines. Then coming to this point, if I define automation, how I can define automation. So, in automation, human, physical as well as mental labor is reduced. In some cases, completely eliminated. If it is fully eliminated, then it is called fully automated system. So, automation is the use of energy of a non-living system to control and carry out a process or process operations without human intervention. The primary objective of this automation is best use of available resources, material and money, and other objectives are same as mechanization. Then partial mechanization and automation. Automation may be partial mechanization and automation. As far as name is suggests, suppose you have a number of operations, some operations are controlled by motors, say for you are using a conveyor, a transfer line say. Some machines are there, such as lathe, milling, just for example, drilling, boring. You are for material movement, you are using some conveyor. And other machines are maybe manually. So, this type of mechanization is called partial mechanization and or automation. That means, here a part of energy is replaced, human energy is replaced by that of a non-living system to carry out a process or process operation, excluding control both in mechanization and automation. As I told you, in full mechanization and automation, as far as name is suggests, every operation is controlled by non-living sources of energy. All human efforts is replaced by the energy of a non-living system to carry out a process or process operations. Now, single unit mechanization or automation, it implies partial or full mechanization or automation of a primary component of a process or process system, excluding control in mechanization and automation. These are the some very basic definition of partial automation or integrated mechanization. What is integrated mechanization? It is defined as partial or full mechanization or automation of two or more primary components of a process or a system excluding control in mechanization and including it in automation. Now, how to quantify this? In fact, in mechanization automation, single unit automation, partial automation, full automation, these are characterized by 1 to 10 numbers. Number 1 identifies mechanization automation of a single operations. Number 2, it is a single, a complete process. Number 3 identifies mechanization automation of a system of processes performed at a workstations. Number 4, process performed in a workshop. Number 5, a system within a group of identical workshops. Number 6, it is within a plant. Number 7, in fact within manufacturing companies. Number 8, automation within a economic region. Number 9, in within a industrial sector, and number 10, in fact country's industrial complex itself. Now, how do I evaluate mechanization or automation? This evaluation is done by some index we call automation index or automation index or mechanization index. What is that? This is actually suppose if I define it in terms of energy, suppose energy from non living sources plus energy from living sources. From living sources. Now, you see, if you observe these things, these living sources means actually the operators labor. If it is 0, what happens? That means this automation index becomes 1. That means this system is fully automated. Based on this index, I can tabulate the level of automations. Prior to coming that, this is one method of measuring automation. Another method of automation is in terms of time, that is k is equal to T mac, k is equal to T mac. It is of course mechanization index like time mac plus time man. K is an coefficient of mechanical. T max is the length of time during which the machine performs the operation without the worker's assistance, and T man is the time during which the human operator assists the manufacturing process, sometimes idle or auxiliary time. Like this, this coefficient can be found by T auto plus T man in terms of time. First one is in terms of energy, second one is in terms of time. So, the same thing if I different index. Now, degree or level of impact of mechanization and automations. What is the physical significance of, say for example, low level automation? 0 level automation means all energy consumed by the manufacturing system is coming from the living sources of energy. That means all our operations are performed by the operator itself. If this is a low level automation, 0.01, what does it mean? If it is varies from 0.01 to 0.05, what does it mean? If it is 0.5 say, that means out of 100 kilojoule energy, only 5 joule is coming from the non-living sources of energy, and operators have to perform 95 joule. Only 5 joule is coming from electrical or hydraulic energy. Likewise, minor automated, likewise moderate automated or mechanized, likewise advanced automated. 0.9 means 90 joule is coming from non-living sources of energy. Only operator has to perform 10 joule energy, and if it is a high level of automation, same as thing, then if it is a full automation, operator's energy is 0 itself. All energy which are converted into work is coming from the non-living sources of energy. So, in this lecture what I have discussed? I have discussed what is mechanization, what is automations, and how do I evaluate this, how do I label this automation, whether it is full automation or whether it is partially automated things, and what are the tangible benefits I can expect from a mechanized or automated systems. I hope that you have understood my lectures, and we will meet in my next lectures. Till then, goodbye.